Look at this pan. 2 years ago, it was black, glossy, and food slid right off it. Today, it's gray, it's flaking, and every egg you cook in it sticks like concrete. This wasn't bad luck. This was the plan. The coating on that pan, polytetrafluoroethylene, or PTFE, was never designed to survive contact with a metal spatula, a dishwasher, or a stove burner cranked past medium. And here's the part they don't put on the box. Once that coating scratches, it doesn't just stop working. It can start shedding. Today I'm going to show you the exact temperature and the exact physical mechanism that kills a non-stick pan. Then I'm going to show you the $15 fix that makes your next pan outlast this one by years, and the one thing you can do with the pan you already own, starting tonight. Here's the physics. PTFE is a fluoropolymer, basically a plastic chain of carbon and fluorine atoms twisted into an incredibly slick, non-reactive coating. That's why nothing sticks to it. It's also why it's practically frictionless against a spatula. But that same molecular structure has one weakness. Heat. Research on PTFE cookware shows the coating stays chemically stable at normal cooking temperatures. Today's nonstick and Teflon cookware is considered safe for everyday home cooking, as long as temperatures do not exceed 500 Fahrenheit or 260 degrees Celsius cross that line, and the chemistry changes fast. Once a pan reaches around 260 degrees Celsius or higher, the nonstick coating can start to break down, releasing fumes you don't want in your kitchen. And here's the part almost nobody times. It only takes a couple of minutes on high heat for an empty pan to reach that 500 to 600 degree danger zone. That's not a defect. That's basic thermodynamics. A light empty pan on a high output burner heats up almost instantly because there's no food or oil there to absorb the energy. This isn't a manufacturing accident. This is a materials engineering trade-off. The same polymer chemistry that makes food glide off your pan is the chemistry that turns fragile the moment it's scratched or scorched, and scratching makes it worse. Once the surface is broken, you're no longer cooking on a sealed polymer layer. You're cooking on exposed aluminum with loose fragments sitting on top of your food. You can't repair a scratched PTFE coating. There's no at-home fix for that, and anyone telling you otherwise is selling snake oil. But you can engineer the failure out of your kitchen entirely. Here's the protocol. Step 1. Stop the scratching at the source. Swap metal utensils for wood, silicone, or nylon. This costs about $8 for a basic set at any hardware or kitchen store. Metal utensils can lead to scuffs and scratches on the nonstick surface, reducing the life of your cookware. This is pure load distribution. A soft utensil spreads pressure across a wider contact area instead of concentrating it into a hard scoring line. Step 2. Never preheat it empty. This is the thermal dynamics fix, and it's free. Put oil, butter, or food in the pan before it goes on heat. The fat and food act as a heat sink, pulling energy out of the coating as fast as the burner puts it in, which keeps the surface well under that 500 Fahrenheit failure point. An empty pan has nothing to absorb that energy, so it spikes straight past the danger zone in minutes. Step 3. Get a $15 infrared thermometer. Point-and-shoot IR thermometers run about $12 to $20 online or at an auto parts store. Aim it at the pan surface before you add food. If you're consistently over 260 degrees 500 Fahrenheit, dial the burner back. This turns eyeballing it into an actual measurement, basic quality control, borrowed from industrial kitchens. Step 4. When it's time to replace, buy the coating that fails safer. If a pan starts to degrade or you're in the market for a new one, an uncoated pan or one without PTFE, like ceramic, stainless steel, or cast iron, is worth considering. Modern PFOA-free nonstick cookware has no proven risks to humans, according to the American Cancer Society, but it still has the same scratch and heat vulnerability. Stainless steel and cast iron have no coating to fail at all. They're a load distribution and thermal mass fix baked into the material itself. Step 5. Know the visible failure point. When a Teflon coating starts to visibly deteriorate, excessive scratches, peeling, flaking, or chipping, it's ready to be replaced. That's your inspection checklist. Then, run your finger along the surface once it's cool. If you feel any roughness or lifting, that pan's job is done. Let's talk business model, and let's keep this about the system, not any one brand. A non-stick pan that's engineered to hold up for 15 years costs more upfront, thicker base metal, a reinforced multi-layer coating, tighter manufacturing tolerances. That's a smaller profit margin on a purchase you make once. A pan engineered around a 2 to 3 year coating life with a retail price that stays low enough to look like an impulse buy. That's a purchase you make 5 or 6 times over the same 15 years. From a pure revenue standpoint, the second model is more profitable, even though it's worse for you and worse for landfill volume. That's not a conspiracy. That's just the math of a consumable goods category competing on shelf price instead of lifetime cost. The fix isn't outrage. It's shopping differently, comparing pans on cost per year instead of cost per unit, and choosing utensils and heat habits that get you the most life out of whatever you buy. Here's the thing nobody tells you. Physics that breaks a pan is the same physics that saves one. Keep the heat under 500 Fahrenheit, keep the metal off the surface, retire it the moment it starts flaking. That's it. That's the whole system. Every time you fix, or simply outlast, something they designed to wear out, you take a little bit of your power back. If you want to stop renting your own kitchen from the appliance industry, then hit like so. The algorithm shares this with someone else who needs it. If you found this useful, hit subscribe, and I'll see you in the next one.